All right, hello everyone. So today we're going to have a look at pensions, which is another form of just installment investment, except, well, obviously it's pensions. So pensions are slightly different, okay? Um, in pensions, you have really two ends of the scale. You have what you would like out of it at the end and what you're putting into it now in order to determine that end, okay? So you have kind of a future payout or a fixed amount you're going to get each month, each year out of a pension. But for that, you need to know at the start how much you're going to have to put in and then divvy it out over the course of the next couple of years, that type of thing. So listen, it uses a kind of variation of this formula. It uses a slight variation of this formula, very slight. So basically what you do is you just manipulate this formula to get the principal, the initial amount on its own. So each installment of your pension should be something like this. So each installment will be one of these. It'll be, your final amount that you want divided by the interest to the power of the number of installments. So I'll show you what I mean. So for example, again, we're talking about a geometric series. So let's say you have 40 years for your pension, okay? And you want to figure out how much you need to put in now in order to get a guaranteed amount of P out. So let's say you know what P is. Sorry, let's say you know what the final amount is that you're going to have to put in. Okay, well, it's just going to be whatever the final amount of your pension over 1 plus I, plus, you get the idea here, final amount of your pension over 1 plus I squared, right up to, final amount of your pension over 1 plus I to the power of 40 years. Okay, so obviously when you sum all that up, you got your SN formula again. Okay, so it's going to be, you've got your A is going to be, F over 1 plus I, and your R is going to be 1 over 1 plus I, because that's all you're multiplying by, 1 over 1 plus I, and then obviously, T is just going to be 40 years. So to put all that together into your little formula, for want of a better word, so you're going to have Sn is equal to A bracket 1 minus R to the N over 1 minus R. So Sn is going to be equal to, so this will be your final amount, okay, or no, sorry, this is going to be your initial amount, okay, present value, cost, present value I think it's called, or cost of your pension at the start, and there's your principal, if you want to call it that, is going to be equal to, well, A over 1 plus I, bracket 1 minus R to the N, 1 minus 1 over 1 plus I to the power of 40 over 1 minus 1 over I. Sorry, didn't need to put a bracket there. So that's what it is. Now, listen, you can do a bit of cancelling here if you really, really, really want to, okay? But it's not necessary to do the cancelling. You don't have to. If you think about it, you've got a fraction up here, a fraction there. You could turn them both into fractions, easily enough, and then worry about it later. But you don't have to. I would not derive that out, okay? There's no need for it, because you're going to sub in values here anyway. It's more important that you know how to set this up and know where the points go than doing any of that, as it is, okay? But, it is what it is if you want to do it that way. So I'm going to leave it like that. I'm not going to try and derive it out. I don't see the point, honestly. Don't see the point. If you really need to, you could, okay? So, listen, I'll leave that there, and we're going to try one. So, give this a read. Show how the present value of an annuity involving depositing $3,000 per year in an account for 6 years can be written as a geometric series. Fair enough. And given that the interest rate is 8% per annum, figure out the present value, the future value, and we'll deal with the rest of them. Okay? So let's have a go at this. This should be doable. Okay? So we've got $3,000 a year. And what we're really looking for is the future. Sorry now about that. Sound. So $3,000 a year. So that's our starting point. Okay. So present value. Let's work that one out then. That's going to be, well, we have $3,000 at the start of the first year, and then we have 3,000 over 1.08 to the power of 1 plus 3,000 over 1.08 squared plus 3,000 over 1.08 to the power of 5. So you have 6. Now, so, right. So, the question you might be asking is, where is this one coming from? When you think about it, you put $3,000 in, you didn't automatically earn interest on it. This is the interest on it after 1 year. Okay? There's the interest on it after 2. You get the idea. So that's where that's coming from. Okay. So let's put this all together. We've got our A, 1 minus R to the N. Sorry about that sound. R to the T, keep using N, over 1 minus R. I'm going to get the calculator out for this one because, bracket 1 minus 1 over 1.08 all over 1 minus bracket 1 over 1.08, and I need to close off that bracket. 12,900 and whatever that is, 86, is it? That's what it looks like. Yeah, 12,936, sorry. Okay, so, and 38 cents. So that's the present value of it that I'd have to put in to get that out at the end. Okay, now the future value, well, obviously we're just going to add them all up. Okay, the future value is just each year. 3,000 for the first year plus 3,000 for the second year, right up to the last year. Okay, so that's 3, 1, sorry, that's 3, 1, 2, bracket 1.08, that's that. So we've got a mixture here, 1 minus 1.08 to the power of 6 all over 1 minus 1.08. So this is our investment because, we're seeing this every month. So that first one was our pension. And this is air quotes here. That's our pension version of it. And this is just our installment version of it. So I only have to do tiny changes to here. 3, 1, 2, 3, bracket 1.08 multiplied by 1 minus 1.08 power of 6 divided by, it's a bit of a haze, 1 minus 1.08 equals 60. That looks up too big. Something wrong. Oh, okay. Right, sorry. I have to do this again. I had a division in there when it shouldn't have been. So 3000 multiplied by 1.0, that was way too big, equals that. Multiplied by bracket, fraction, 1 minus, in a bracket, 1.08, close bracket to the power of 6, over 1 minus 1.08, and then close that whole bracket. That makes more sense. 20, how the other thing was again. So future value is going to be €23,768.41. So we've got the present value of it, and we've got the future value of the annuity. Okay, so that's, in other words, $3,000 per year as a geometric series. Okay, so if you put it, all right, yeah. So the last bit, if you look at that last bit, it's just your simple compound interest. If you did the same thing again at just basic compound interest, what would you get? Well, that's an easier sum. Okay, that's just $3,000 bracket 1.08 to the power of 6, $4,000. Jesus, that just shows it. Oh, sorry, no, it's not $3,000. It's the present value, whatever that was. I don't know how I just put $3,000 in there. It was the present value, 12,936. Oh, it's not too, it's close, but it's, you were actually better off doing it. Interesting. Okay, you'd be better off doing it by putting the $3,000 a year in for the 6 years and letting it work its way up, than by actually putting in the how much the $3,000 would be worth in 6 years. So that's a very interesting one. I didn't think about that one. Yeah. So right. So that is pensions. So hope that gives you a little kind of a taster. Okay. So just to kind of get your head around this again. Okay. The difference between present value and future value, because you are going to need to understand this. The present value will always be, in terms of geometric, it'll always be principal plus, or whatever, f, whatever you want to call it, p over 1 plus r plus p over 1 plus r squared, you know. That will always be to find the present value. To find the future value, though, okay, it's always going to be p bracket 1 plus r. So there's the difference between the two of them. Okay, the future value, you start with a multiplication. The present value, you start with the first lumpy sum, whatever the hell it is. Okay, so that's the subtle difference of it. Okay, that's the subtle difference. They look very similar, but this one starts with the number on its own. This one starts with the full sum, and you're just incrementing by the power. Okay, you increment. So when you're doing your A, that's why it's very important to do this, because when both of these are derived then into your SN formulas, this will have an A of P, whereas this will have an A of P bracket 1 plus R. That'll have an R of 1 over R, 1 plus R. That will have an R of just 1 plus R. Subtle difference. Okay, and they'll both have the same T for whatever it is. It'll be the same. Okay, you know, T is T or whatever. But that's the subtle difference between the two of them. Okay, thank you. Bye.